Let's talk about some three-dimensional figures. So first of all, we need to define what a polyhedron is. Polyhedron is a solid that is bounded by polygons. So polygons, we know those have many sides, and polyhedron, that's where it gets its name. So we're going to start by looking at a rectangular prism. A rectangular prism has bases that are rectangles. Because the bottom base and the top base are both rectangles, we have something called a prism as opposed to a pyramid. When we want to talk about the polygons that make that prism, we're talking about the faces of the prism. The vertices are the vertex of each of those polygons, and the edges connect the vertices. So here we have a triangular prism. It's called a triangular prism because the bases are triangles. So whenever you're working with prisms, check to see, are there any other faces that are not rectangles? If there are, those are the bases. Bases are triangles, even if it's lying down flat so you can see it. It looks like the base itself is a rectangle, but that's actually a face. The two bases are these triangles, and those triangles are how we name it, triangular prism. Two bases connecting them, but oftentimes our book and our drawings are going to give them to you lying flat like this so you can see the bases and can actually do some calculations later with them. So a triangular prism. And finally we have, this should be noted that these are right angles and these sides are congruent, but this is a square pyramid. A square pyramid has a square for a base. And because it doesn't have two parallel squares for bases, it only has one, it comes to a point at the top. It's called a square pyramid. The height of a prism is the distance between one base and the other. So the height of this prism, this triangular prism, is how long the segment is that connects the two bases. That's considered the height. So we want to decide whether each of these solids is a polyhedron or not, and if it is, name it. So first check, are all the faces, is the base, a polygon? All right, this one is yes, it is a polyhedron because it has only polygons for faces and bases. So we need to name it. So first of all, we can ask ourselves, is it going straight up and down? In other words, is the height of this figure going to be perpendicular to its base? And if that's true, you say yes, it's a right polyhedron. Okay, a right polyhedron. And it's not slanted, so it's not called oblique. We also need to figure out what its base is. So we count the sides, 1, 2, 3, 4, 5, 6 sides. So it's a right hexagonal. And then we check and see, is it a pyramid or a prism? Does it have two bases that are connected, or is everyone going to a point? Does it have faces, lateral faces that are triangles? And since it does have triangles for faces, this is called a pyramid. Next one, is this a polyhedron? And we're going to say no, because the base of this, even though it's upside down, this cone has a circle for the base. And when it has a circle, it's not a polygon, so it is not a polyhedron. Three-dimensional solid, not a polyhedron. How about this one? That's easy now. This is a no as well, because we have a semicircular base or some sort of a curved base. And finally, is this a polyhedron? And we're going to say yes. And it's a right, because we have perpendicular lines between the two bases, and a right triangular prism. Triangles for the bases even though they're facing us, and prism because we have two bases that are connected. So how many faces, edges, and vertices does this polyhedron have? So we're going to look at something that looks like a Toblerone candy bar. So here we go. We need to find the faces. Well, first of all, we have a triangle for a base and another triangle for a base. So there are two triangular bases and then three other faces, one to the back, one to the bottom, and one that's facing us. So we have a total of 5 faces. How many edges do we have? Let's grab a different color here. Edges. Well, the edges are what connects the bases together, or the polygons together. And so we have one edge here. Here's the second. Here's the third. 6, 7, 8, 9 edges. And finally, we need to figure out how many vertices we have. So we want to count all the points. 1, 2, 3, 4, 5, and 6 vertices. All right, I want you to name the other polyhedrons that are on your notes sheet. Ask yourself, right or oblique? Here's a right. What kind of base does it have? I see 1, 2, 3, 4, 5, 6 sides, so hexagonal. Is it a pyramid or a prism? It's a pyramid. This is what we mean by oblique. We'll need that when we talk about volume. An oblique prism is one that is not perpendicular. The bases are not perpendicular to each other. They don't form right angles with each other if we connect the heights. And so this one is an oblique. And then it has a triangle for the base. So an oblique triangular prism, not a pyramid, has 2 bases that are parallel to each other. Okay, so you should have the idea. And that is what we're doing next.